This is the Word document that you are going to get in your assignment. We are moving on to physics. So this week, you are going to be finishing up any quizzes that you haven't finished up. Today, I'm going to try and make sure you have a list of which ones you haven't done. Although, if you just open Schoology, if there is a quiz there and it doesn't say extra practice, then do it. That's basically how it goes. But in order to maybe help you with that, I will also try and get you guys a list. Hopefully that will happen sooner rather than later, but you know how the day goes, right? Yeah. Anywho, so this will be the Word document that you have this week, and yours will be filled in. So everything that I type in here will already be in your copy of the document. So it's got all this sort of notes section, which I got a little crazy on and went around color coding everything. Took me hours. It was ridiculous. Anywho, so yes, physics. Where were we? Yeah. Oh, we only got 16 people this morning. Hopefully everyone else is going to watch the video. Okay. So quantities are a big part of physics. And every quantity that you have has a unit or different units, maybe several units associated with it. And one of the things that confuses people a lot is, what do we mean by the quantity and what do we mean by the unit? Well, the quantity is the thing that we are measuring. So if we're measuring distance, the unit is the thing that we measure it in. So the unit would be the meters, okay? And the symbol for the quantity is D. The symbol for the quantity is not M. M is the abbreviation for the unit. So I've tried to color code this. You know, red and orange are sort of related colors. So I've got the quantity is in this document will always be this sort of pink color. The symbol for the quantity will always be orange. The unit will always be in blue. That's going to be the full word for the unit. And then the abbreviation for the unit is always going to be in lowercase. So you're probably aware that distance is measured in meters. And you probably already know that if you're measuring the quantity of time, you're going to measure it in seconds. Of course, you could measure it in hours or days or weeks, but the official unit for time is the second. So that's the one we're going to use today. So that's the unit. We abbreviate seconds as lowercase s, and we abbreviate time as lowercase t. So the symbol for time is lowercase t. It's important for you to note when you're writing the symbols and the abbreviations, whether you have a capital letter or a lowercase letter. If you write lowercase t, you mean time. If you were to write capital T, you would be referring to temperature. Very occasionally there is some overlap in the very occasionally there's some repetition of symbols. So you'll have, for example, I think C both means the speed of light, lowercase c. Does it mean anything else? No. Never mind. I'll think of it as we come to it. Okay, I notice we've had 3 more people join us. I was just saying that this document, you have everything that's in here provided to you in this week's assignment, and it will all be filled in, so you can either copy down notes or you can just watch and see how it goes as we go through. Okay, so we're going to do something with distance and time. Can anyone think of something that we could calculate using the distance and the time? Maybe something you've calculated in math class or something like that. If I gave you the distance that a car traveled in an hour, what could you calculate? How fast? Absolutely. You could calculate how fast. So you're calculating the speed. Okay. And there is a formula for speed. And we are going to be working today with formulas. Formulas are all going to be in purple. All right. you are going to be showing work. The showing work is sort of highlighted in a light yellow color. And you can see down here that every problem solving method has 6 steps. 1, 2, 3, 4, 5, 6. This might seem like a lot of work to get something that you could probably do in your head, and I'll explain why you're showing your work a little bit later on. But for now, we're just going to get down to it. So, speed. Speed also goes by the name velocity. Velocity. And the symbol for velocity is V. So you'll notice that the V is in orange because that is the symbol, and velocity is in pink because that is the quantity that we are measuring. We can write the formula. Okay, so we have a question here. What is the average velocity V of a ball that rolls 20 meters in 5 seconds? And remember, velocity is speed. Well, the first thing you're going to do is you are going to write down the given information, okay? Anything that is given in the problem. So let's go up to the question and, oh, look, we are given the number 20. So you're going to look for numbers when you're looking for given information. You're going to say, I'm given 20 meters and I am also given 5 seconds. There we go. And you're not just going to write 20 meters and you're not just going to write 5 seconds. You're also going to relate that to what quantity you're measuring. Okay, so if we are looking at 20 meters, what quantity are we measuring? If we're looking at 20 meters, what quantity are we measuring? Distance. Thank you, Michelle. Okay, and the symbol for distance is D. So we're going to write D equals, whoops, that's a 3. D equals 20 meters. And if we're looking at 5 seconds, that is measuring time. Okay. So we are looking at our distance being 20 meters, and we're looking at our time being 5 seconds. Those are the things that are given to us in the question. And we were being asked to find the, when you're asked for the find, you are going to look for the thing that you find. What color do I want that? Sure, that'll do. The thing that we're going to find is the thing that's attached to the question word. Okay, so anytime you're looking for what am I finding, you're going to be like, oh, what? What am I finding? I am finding the average velocity. Okay, so I am looking for velocity, and I don't know what that equals. Okay, step number 2. You are going to write the formula. So V is equal to D divided by T. Whoops, there we go. Step number 3, what you're going to notice is at the bottom of the page, I've said that step number 3, it's going to be required next week, but not this week. This week, you are always going to have already solved for the quantity that we want you to find. So I have given you the formula in the format V, all on its own, is equal to D over T. When you are solving a formula, basically you are isolating whatever it is you want on one side of the equation. But hey, look, V is already all by itself. So we don't have to do that this week. So we're just going to say that that is done. Woo! Now we plug in our given information. So instead of writing D, now we're going to substitute in the 20 meters. So here we go, 20 meters. And instead of writing T on the bottom, so time is actually equal to 5 seconds. So we have velocity is equal to 20 meters divided by 5 seconds. So that is what we call the plug part of this thing. Okay, so we're now going to plug and chug. This is essentially called the plug and chug method. And one thing I forgot because I was too wound up about the clan thing is that when you plug things in, you are going to make sure you also plug in the units. So you want to make sure that you don't just write 20, but that you write 20 meters. And you don't just write 5, you write 5 seconds. By chug, we usually mean you grab your calculator or your brain and you do that math, whatever it is. In this case, we're dividing 20 by 5. I'm going to use my brain calculator because I know that that is 4. And my unit is the meter, whoops, per second. Okay. My final step is to box my answer because anytime I show a lot of work, I want to make it really easy for whoever's marking it to see where everything has gone. So I'm going to grab a box. I'm going to put a box around my answer, and then I don't want to have it filled because otherwise you can't see it. And then the outline, I'm going to put a box around it. Now, you could also, if you preferred, you could write it as V, not capital V, that would be volume. Little v is equal to 4 meters per second. That would also be fine. This notation here, where the M is on top of the S, means the same thing as M/S. That means meters per second, meters divided by seconds. Okay, so if I wrote that as my final answer, I would stick a box around that one. Okay, so your choice, how you write it. Okay, a couple more familiar quantities and their units. Hopefully you are familiar with volume. Volume is our quantity, and one of the units we can use to measure volume is liters. We could use cups, teaspoons, gallons, centimeters cubed, liters. So we're going to use liters here, kiloliters, milliliters. And the abbreviation for liters is a capital L. Okay, not a lowercase l, a capital L. And the symbol for volume is a capital V. Okay, remember little v was for velocity, big V is for volume. And for anyone who turned in late, I want you to notice the color coding in this document. It's going to help you out when you do the questions. Everything that is a quantity is shown in pink. The symbol for the quantity is shown in orange. The unit for the quantity is shown in liters, and the abbreviation for the unit is shown in green. Hopefully you already know about mass as well. Okay, mass, the symbol is a lowercase m, and the unit is kilograms, which is lowercase k, lowercase g. Lots of people want to put a capital K there, and I don't blame you for wanting to do that because in our school driveway, it says 10 kilometers, which just drives me nuts because our driveway, number one, is not 10 kilometers long. What they mean is 10 kilometers per hour, but that's not the K for kilo, unless you're talking like a computer kilo, which is not the same thing. It's a kilo, and it's a, not gram, meter. But apparently they don't ask our custodial staff to have their units memorized, so they just write it like that, and it irritates me every time I drive over it. Okay, I exaggerate, it doesn't actually. Okay, now I'm just rambling on about the capital and lowercase letters, you know, in case you missed the lesson and you need to read about it. We are back to looking at a formula. So we're going to do a formula that this time relates mass and mass and volume can be related to find the density. Okay, density is if you have the same amount of one substance and the same amount of a different substance, one of them is going to be more dense than the other. One is going to have more mass per the same amount of space. So we calculate density as mass over volume, or D equals M over V. So what is the density of rubbing alcohol if 2.5 liters of alcohol has a mass of 1.97 kilograms? Again, we are going to write down the given information, given. So we are given 2.5 liters. What is 2.5 liters measuring? What quantity? And even if you're not comfortable typing it in, answer it to yourself in your head. What quantity is 2.5 liters measuring? Hopefully you answered to yourself that it was the volume, and the symbol for volume is V. So we know that volume is 2.5 liters. We also know 1.97 kilograms. Would it be okay for me to just write it like that? I'm given 1.97 kilograms. Okay. All right. You cannot write it that way. You need to write M equals 1.97 kilograms. Okay, and we want to find, so those were our given quantities, and we want to find the density. So we are going to find the density, and we don't know what that is. So now we're gonna, and we have used the quantity symbols. Notice we did that here. And we included the units, right? Step number 2, write the formula using the quantity symbols. So our formula is going to be this version here, D equals M over V. D equals M, oops, over V. And this week we don't have to do step number 3 because we are solving for density, but density is already by itself. So it is done. And then we're going to plug and chug. But we're going to make sure that we include the units, and we're going to plug that all into the formula. Okay, so density is equal to, we're going to plug in the mass, 1.97 kilograms. And we're going to plug in on the bottom, we need to plug in the volume. So volume is 2.5 liters. And then we chug this into our calculator. This one I can't do in my head. So density is equal to 1.97 divided by 2.5 is 0.788. Can I leave my answer just like that, or am I missing something? I am missing the units, absolutely. So I have to write that in. Kilograms, whoops, kilograms per liter. Or I could write it as kg/liters. And then I am going to cheat by grabbing a box. Box my final answer. There we go. Now, what if you didn't want to write it all like this, you know, D equals D equals D equals? You can do steps 2 through 6 in one line. We can say D equals M over V. And then right after it in the same line, we can do our plugging in. So we would have 1.97 kilograms. And then on the bottom, we would have our 2.5 liters. And then finally, all on that same line again, we could write 0.788 kilograms per liter and box our final answer. There we go. Okay, so you can do it all in one line rather than doing it step by step by step. Okay, let's see. Now, we've been dealing with units that you are probably familiar with. This unit in Science 9 is actually about electricity. And in electricity, we are going to be using some units which you might not be familiar with. So for example, one of the things that we deal with in electricity is charge, because in electricity, charges are flowing. So if you have a wire, there's electrons flowing through that wire. Okay, that's what electricity is. It's from the word electron. It all comes from the same root. So our quantity that we're going to be measuring is the amount of charge, or the quantity of charge, which is why the symbol for charge is Q. You would think, why isn't the symbol for charge C? Well, I'm not exactly sure, but I guess they decided they wanted it to be different. So Q stands for quantity of charge. So it's not really random. It does have a meaning, but it is a little weird that charge is represented by Q. The unit for this is the coulomb, named after Monsieur Coulomb, the Frenchman. I don't know what else he did, but he invented the unit, and it is abbreviated capital C. And what the heck does that mean? What is a coulomb? Well, electrons are so itty-bitty, tiny, small that it is super inconvenient to count them one by one, because there are just millions and billions and trillions and quintillions of them. So in the electricity unit, we often compare electrons flowing through a wire to water flowing. So water flowing through a river, or water flowing through a hose. That would be, we're comparing that to our electrons flowing in a wire. And just like if we were looking at a river, we might measure the amount of water flowing in buckets of water. How many buckets of water are going past a point in a given time? So we could similarly measure the number of electrons in buckets of electrons. So we're going to see this image fairly frequently. Here's our bucket of electrons, and it is 1 coulomb. Okay, 1 coulomb is a bucket of electrons. It contains, let's take a look at this number and see if you remember your scientific notation. 6.24 times 10 to the 18 electrons, or 6.24 quintillion electrons. So if you remember your scientific notation, that 10 to the 18, that means we've moved our decimal place 18 places. So if we start with the decimal place just to the right of the 6, okay, you can watch my cursor move across the screen. We have 6.2, but we're going to move it over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. That's how many electrons are in a bucket. Okay, that's the number of electrons that we call a coulomb. 1 coulomb, of course, can be abbreviated as 1C. And so don't forget, I will be referring to it this way a lot. A coulomb is a bucket of electrons. Okay, our second electrical unit that we will be using this year is current. Not the unit, the quantity is current. And as I was saying, we measure the flow of a river in how fast the current is going. We can measure the flow of electricity in how fast those buckets of electrons are moving. So our quantity is current, and our symbol for current is I, which again, you might think, why is it an I? Well, I should have put it on the same page, but I didn't. Current, I, the I is short for the intensity of the current. So imagine that you have gone inner tubing in a river, and it is a slow, lazy river, and you're just floating down, everything's moving by slowly. That would be a very not intense current. The intensity would be very low. It would be very slow. But if you're in the midst of a very narrow section of the river and it gets really fast, that means that the intensity of the current is so much greater. So I for intensity, how fast that current is moving. Okay. So looking back at our river analogy, if we are measuring current, remember that's our quantity, so it's in pink, we measure it by seeing how much water flows past a point in a second. And we could measure that in buckets of water per second. Our unit is in blue. Current in electricity, which its symbol is, remember, I for intensity of current. How much charge, and remember charge is measured in coulombs, and the symbol for charge is Q, and the unit for coulombs is C, the abbreviation. We measure current in how much charge passes a point in a second. So we could have the number of buckets of electrons passing a point per 1 second. In other words, the number of coulombs per second, or C per S. And we could actually, ooh, look, I could move these electrons. I could start here and be like, oh, how many are going past a point in a second? 1, 2, 3. And you'd have to count how many went by in a second. And that would give you the coulombs per second. So this table is telling us that the unit of current is coulombs per second. But if you remember up here, I told you that the unit of current was the amp. Or maybe I didn't tell you. I think I got distracted and I didn't tell you. The unit of current is the amp, which is short for ampere. You should know the term ampere, but just be aware that we usually just say amps. We don't say amperes. We do, but not often. And the abbreviation for ampere is the capital A. So up top, I tell you that the unit of current is amps, but in the table, I'm telling you that the unit is coulombs per second. And the reason is that those two things are actually the same. An amp, or an ampere, is actually defined as being a coulomb per second. So amps means the same as coulombs per second. Okay. And now guess what? We're going to use our current and our charge in a formula. And we're going to show our work. And remember, I'm going to tell you why it's so important to show your work just a little later. Okay. Current, remember, it is the amount of charge flowing past a point in a given amount of time. So it's the charge per unit time, or the charge, that should be a capital Q. Sometimes they represent it as a lowercase q, but just for consistency this year, we're going to just call it a capital Q. I, current, is equal to Q, quantity of charge, over T, time. So intensity of current, quantity of charge, time. We are told that a charge of 12 coulombs passes through the filament of a car headlamp bulb in 4 seconds. What is the current? Okay, I'm not going to ask you things because nobody is answering me today. It's okay. We're just going to whip through this because we've already been here a half an hour and we don't want to be here for too much longer. So let's find our given information. Anything that is given will have a number. So there's a number, 12. 12 coulombs. 12 coulombs. But remember, I don't just want to write my quantity, my unit and how many. I also want to write the quantity symbol. And remember, coulombs measures charge. And the symbol for charge is Q, for quantity of charge. We are also given 4 seconds. So seconds is measuring time, and time is lowercase t. So that's going to be 4 seconds. And we want to find, let's go find our question word. What is the current? So we are looking for what is the current. That's what we are trying to find. Oh, I don't want to really do that. Okay, there we go. So we want to find the current And remember, current, the symbol is I for intensity of current. And I will give you a hint, if you're typing formulas and stuff, it's really nice to use a serif font. Serif fonts are ones that have like crossbars on the tops of I's and stuff. Times New Roman is really nice. Okay, so often I'll go through afterwards and I'll change all my I's to Times New Roman. Or Comic Sans, or there's various other serif fonts. Okay, so we don't know what current is, but we do know that current is measured in, not slashes. It's measured in amperes, which the symbol is A. Our formula is given to us up here, I. The intensity of the current is equal to the charge, the quantity of charge, divided by the time. How much charge passes a second in a given amount of time. If you think about what current means, it means you don't have to memorize the formula. You can actually just puzzle it out. What is current? It's how much charge flows past a point in a given amount of time. Well, then it has to be Q over T. It has to be charge over time. So people get really wound up about memorizing these formulas when, if you think about them, you don't have to memorize as much because it just kind of makes sense after a while. Remember, step 3 this week is done. We have already isolated I, current. Plug in our given information. Okay, I'm just going to grab this and put it here. I is equal to, now we're going to plug in Q, which is 12 coulombs. And on the bottom, we're going to plug in our time, which is 4 seconds. So we have plugged, and now we are going to chug through the math. Okay. So 12 divided by 4 is 3, and my unit is coulombs per second. And you'll notice I added something a little bit more here. You're going to box your final answer, and you will change the unit if necessary. Not that it is incorrect to write I as coulombs per second, but nobody ever gives you current in coulombs per second. So let's rewrite it as 3 instead of coulombs per second. The same thing as coulombs per second is A, which stands for amps or amperes. And we will box that. Box, box, box. Where's my box? There's my box. Okay. Let's just see what it would look like quickly if we were to do it all in one line. So we would have I. Let me make this Times New Roman. Here we go. Times New Roman. I is equal to, if anyone's interested in how I type these things, I type Control U to underline, and then I usually give myself like 1 space, even though you can't see the underline, it will start. And then I say, oh, I is equal to Q, and then I go space, and then I press Control U to stop my underlining, equals, and then I bop down here and I go, I is equal to Q over T, Control U to underline. I plug 12 coulombs, Control U to stop underlining, equals, and I plug in my 4 seconds, and we get 3 coulombs per second, which is equal to 3 amps. And I give myself a little space so I have room to throw a, oops, I don't want to paste into my text box. I want to paste somewhere else and drag it on top of my text box. There we go. Okay, so that's how you could do it all in one line. And that is all we're looking at today. We're just getting used to working with units, used to showing our work. So one thing you're going to do is you are going to type your answers directly onto this worksheet this week. Okay? So you are going to type it in, and then you're actually going to submit it. You know how normally I just have you say done? This one doesn't have an answer key. I want you to submit it so I can take a look at how you're showing your work, okay? Everything's nicely color-coded here. Look, we have 6 quantities in this handout. The quantities will all be in pink. The symbols will all be in orange. The units will all be in blue, and the abbreviations will all be in green. There's a few more questions here. Okay, and then there's a place for you to write the 3 formulas given in this document. You're going to start by giving the full names of the quantities, and then over on the right, you're going to give the symbols. So you're going to write the formula 2 different ways. Finally, question 5. You should solve the following problems using the SIP-STEP method. You may show all your work in one line if you wish. And remember I said I was going to explain it? But Miss Benz, that sounds like way more work than just pushing buttons on my calculator and writing down a number. Why should I bother? Well, because in university, you might get a question like this. Okay, and it gets pretty ugly pretty fast. Just make this a little bigger so you can see it. Okay, and maybe I'll move this arrow out of the way because it's just in the way right now. So you might start with this formula up at the top here, and you might discover, oh, I need to solve for this, and I've got, oh my God, what just happened there? Well, if you write down all of your variables, and then you plug them all in, and you plug in your units, one thing that you're going to start doing is you're going to start canceling out units that are both on the top and on the bottom. So if you look here, I have coulombs, and I also have coulombs, and coulombs times coulombs is coulombs squared. Look what I have on the bottom. I have coulombs squared, so I can actually cancel that out. I also have on the top, I have meters squared, but I notice on the bottom, I have meters, and then outside the brackets, I have a squared. So my meters squared on the bottom is also going to cancel out. And the only unit I am left with at this point is the little old Newton right here. And you can see everything cancels out and I get the Newton. This is how I got through high school physics, was just having all my units and making sure they canceled out to give me, like, I wanted to have the unit of force, a Newton. Did I do it correctly? Yes, because all my units canceled out properly. Now remember, if this looks terrifying, this is something that you would do in university, which means that you're going to start in grade 9 with really simple formulas. You're not going to have anything more complicated in grade 9 than a 3-variable formula, 1, 2, 3. Okay? But you want to practice writing those quantity symbols and the units and showing all your work, because eventually, 4 years from now, you might have to do something like this. And it looks terrifying right now, but by the time you get to university, if you practice this skill, it won't look terrifying. It might look like it will be a pain in the arse to do because it's long and involved, but you won't be scared of it anymore because you'll have done this in grade 9. In grade 10, I think they might throw in 1 extra variable or a square, but again, it's pretty simple. In grade 11, it gets a little more complex, and then in grade 12, a little more complex yet, but we work you up to it very, very slowly. So this year, you are just going to practice, using those formulas. I will clean that up later. Practice using the formulas, practice showing the 6-step method of showing work. So I would really prefer it if you type in your answers, okay? So I'm gonna press Control U, and if you are unable to figure out how to type your answers in, because the document is there and you can edit it, but if you're having troubles, you could, in theory, print this out and then take a picture and then cut and paste the picture into the document. Okay, that would also be possible. Okay, but I would really prefer it if you type in your answers, because typing in your answers is going to be a super useful skill. If you're typing up a lab report, it's really nice to know that, say, you know, you can control U to underline things and control U to ununderline things, and so on and so forth. And the more practice you get, the better you get at it. This worksheet is due tomorrow. I know you're like, oh my God, it's due tomorrow. There's like no questions on this. It's going to take you half an hour tops, and tomorrow is a flex day. And you have all day tomorrow. It's not due till like midnight tomorrow. And you know what? If you were to hand it in on Saturday morning, am I going to get really wound up about it? No. What I want you to do is I want to have some time before next week to take a look at your problem solving and make sure you're doing it the right way. Okay, I want to be able to give you feedback by next week. And if I wait until in the middle of next week, then that's going to be a problem. So try to get this done by tomorrow. If it's in on Saturday, don't panic. It's all good. If there's some reason that you absolutely cannot get it done until later, then you need to just send me an email. I probably can be flexible about that. The other homework is to finish any Schoology quizzes. Any Schoology quizzes, and I'm just about to go on there and make sure that you know which ones you have if you can't figure it out for yourself.